Okay, with this video, we are starting our final topic of the course, and that is probability and counting. Okay, in this particular video, we're just going to introduce the very basic concept of what probability is, which really is a middle school topic. So hopefully this video feels like it's very, very familiar to you as far as the types of math that we're doing in this particular video. And then in the next couple of videos that come after this, we'll introduce the concept of counting, which seems like that's something you should already know. But of course, this is high school math, so it's going to be counting with a twist. And then we'll get into using counting and probability together to find the probability of more complicated situations. And that'll be the end of our class. So that represents just a couple videos worth of material, and then we're done for the school year, which sounds great. All right, but without getting too far ahead of ourselves, without wishing the summer upon us, let us start with the learning objectives and take a look at what we're doing here, okay? Learning objective, just to calculate very simple, very basic probabilities. That's our main learning objective. In fact, at first that was going to be our only learning objective. But I did decide that I want to approach learning objective number one. I want to approach the ability to calculate simple probabilities by using what I call a functional definition, okay? Using a functional definition. And what I mean by that is we're not going to write out some formal definition like what you would find in a dictionary. We're going to write out a definition that then tells us how to do learning objective number one. The definition itself will tell us how to do a simple probability calculation, okay? So with that said, let's look at that basic definition. So we're going to say that the probability, whoops, I spelled that wrong. The probability of an event is going to be equal to the ratio. And remember, ratio just means it's a big fraction, okay? So the ratio, the fraction, the ratio, where we calculate the number of ways, or we count up the number of ways that the desired outcome can happen, okay? So the number of ways a desired outcome can occur, okay? Now, that's not your normal math formula, right? We're used to just seeing symbols and letters and stuff. And here I'm basically writing a sentence. The probability of an event is the number of ways that the desired outcome can occur, okay? So the desired outcome that I'm referring to here, that is the same as the event that we're trying to calculate, okay? These two things are the same thing. So realize that if you think about when you've seen probability in real life in a newspaper or something like that, the desired outcome is not always a good outcome, right? So if I'm studying like winning the lottery, then the probability of winning the lottery is the number of different ways I could win, right? That's a good outcome. But if I'm studying something bad, like, you know, recent history, if we're studying the probability of catching COVID-19, the probability of catching COVID will be the number of different ways that you can get COVID, all right? So that's a situation where the desired outcome is a bad outcome. But either way, however we want to take this particular event, we're going to figure out how many different ways that that event can occur. That's what we're doing right here. Now, that's only half of our fraction. We still have the bottom half of the fraction, okay? So the bottom half of the fraction is the total number of possible outcomes associated with the event. Okay, the total number of possible outcomes associated with the event, right? So here's what I mean by that. So let's take the lottery ticket example for a second. The number of possible ways of winning the lottery. So I'm calculating the probability of winning the lottery. That's what I'm calculating, the probability of winning the lottery. So the desired outcome is that I win. Now, let's just say for simple discussion that we're talking about a lottery where they just, you know, they draw a ticket out of a hat or out of a barrel or whatever, and whoever wins is the one ticket they draw. So there's only one way you can win. They draw your ticket. That's it. So the top of my fraction would be a 1. The total number of possible outcomes would be all of the possible tickets that they might draw out of the barrel. So if I buy a lottery ticket and 50 of my friends buy a lottery ticket and they put all the tickets in a barrel and they pull out one winner, then there's one way that I can win, and there's 50 possible outcomes altogether. And so that's what we're talking about. If we take the COVID example, if we want to calculate the probability of catching COVID, now we have to catching COVID based on what? Okay, so catching COVID, let's just say based on going to the grocery store, all right? So I take a random trip to the grocery store. What's the probability that I catch COVID if I go to the grocery store? So some smart scientists would have to sit down and conduct an experiment of some sort to figure out the total number of possible ways that I actually end up catching COVID. So first of all, I'd have to meet somebody who has COVID. Second of all, they would have to be in the contagious phase of the disease. Third of all, they would have to, so you can see there's lots of complicated things that go into this. But then the total number of possible outcomes, well, there's all the different ways that I could catch COVID, plus there's all the different ways that I don't catch COVID. So maybe, I don't bump into anybody with COVID, or maybe we're all wearing masks, or maybe there's all kinds of things that can change the probability here. So you can see from these two examples, the lottery ticket example, fairly basic, pretty straightforward. There's one winning ticket, there's 50 in the barrel, probability of winning, 1 out of 50, okay? The COVID situation, much, much more complicated. That requires lots and lots of study of all the potential outcomes where I do catch COVID, divided by all the potential outcomes, both catching COVID and not catching COVID both. So it can get very, very complicated. So this is kind of introducing what this unit is about. In this video, we're going to work with very simple probabilities. So more like that lottery ticket example. But as we move through the unit, by the time we get to the end, we'll progress to things that are a little bit more complicated. Now, we're never going to get quite as complicated as the COVID system. That would require us to all understand the nuances of contagious diseases and all sorts of socioeconomic different types of data. We're not going to get to that place, okay? But we will get to things that are significantly more calculated or complicated than one ticket in a barrel out of 50. All right, so with that said, we're going to take a look at some examples. And what I'm going to do, I'm going to show you 3 examples, and I'm going to move from easiest to hardest. But all 3 of these, like I said at the beginning of the video, all 3 of these are middle school level examples. So example number 1 is, what is the probability that I flip a coin and I get heads? Okay. Find the probability that I flip a coin and I get heads. Now, in everything that we do in our class, we're going to assume that it's a fair situation. So I've just got a normal quarter here, nothing fancy about it. If I can kind of get it where there's no glare, there's the side with the head, there's the George Washington side, and then over here, there's my tails. This particular one, I'm not sure what state this is, but anyway, prairie grass. It just says prairie grass. I don't know. Okay, so there's my coin, heads, and prairie grass is tails. So if I think about this functional definition, my probability is going to be equal the total number of possible ways that I could flip this and get heads. Well, it's pretty straightforward. There's one head. That's it. If I flip it and I get heads, then I just achieved the desired outcome. So there's one possible way, which is to get a head on the coin. Now, if I flip the coin, I could get a head, but I could also get a tail. So there's 2 total possible outcomes. So notice total number of outcomes, both desirable and not desirable. So there's 2 possible outcomes. Get a head and get a tail. 2 outcomes. And so the probability that I flip a coin and I get a head is going to be 1 out of 2. Now, I will say in our class, we will almost exclusively write our probabilities as decimals. So of course, 1 over 2 as a decimal, that's going to be equal to 0.5. And we'll write almost all of our probabilities as decimals. It is legal and possible to write it as fractions. You'll see that in real life examples. You also could write it as a percentage, right? If I move this decimal 2 spot, then that would be a 50%. So that's telling me that I should expect that approximately 50% of the time I flip a coin, I should get ahead, assuming that it's a fair coin, all right? So this is the idea of a probability. That's a very simple one. Let's move into one that's just slightly more complicated, all right? Most games that you play, board games or what have you, use dice. And the typical die that you use has 6 sides to it, shaped like a cube. So it has 6 sides to it. So I just happen to have here a 6-sided die. Again, we're going to assume that it's a fair die, that every side is equally likely to show up. What I want to do is calculate the probability that I roll the die and I get a number that is less than 3. The probability of rolling a die and getting a number that's less than 3. Okay, so this particular die actually has numbers on it instead of little dots. Okay, so I don't have to worry about counting pips or anything like that. I've got the actual numbers here. So my probability is going to be the total desirable outcomes divided by the total possible outcomes. So I often will start with the possible outcomes, especially if it's something I'm familiar with, because that I don't really have to think about. If this thing has 6 sides on it, then how many possible outcomes are there? Well, there's 6 outcomes. Each side is a different possible outcome. So I could roll it and get a 1, or I could roll it and get a 2, and so on and so forth. And all of those things are possible outcomes. So that would be the bottom of my fraction, that there are a total of 6 possible outcomes. Each side is a possibility. Okay, so that's one thing. Now, how many of my sides don't have a number that's less than 3? Well, obviously not all of them do. Like if I rolled this, that's not less than 3. If I roll this, that's not less than 3. All right, so how many of my sides are actually less than 3? Well, there's the side that has a 1, that's less than 3. And there's the side that has a 2, that's less than 3. But those are the only sides. So the number of ways that I can get the desired outcome, which would be a number that's less than 3, there's 2. I could roll a 1 or a 2. Those are my possibilities, roll a 1 or a 2. So if I simplify this, or like I said in our class, we'll usually write it as a decimal. If I switch that into a decimal form, that's going to be 0.3 repeating. Okay, so my probability is 0.3 repeating. If you choose to round off, just like we've done all year long, I'm not going to mind at all. That's totally fine to do. Typically, we round off so that it will fit in an SAT grid. So that would be 0.333 if I round it off that way. Right? So there's our basic idea. The most common example that we're going to look at in this particular video is example number 3, and that has to deal with a deck of cards. Now, with decks of cards, the one thing that's a little bit tricky is that I know that for a variety of reasons, not everybody who studies algebra is familiar with decks of cards. So just a little basic information. A deck of cards has a total of 52 cards in it. There's 52 cards in total. Okay. Now, those cards are numbered from 1, which we call an ace. So an ace is a 1, up to 10. And then there's a jack, queen, and a king. So there's a total of 13 cards, and then the cards repeat. Ace all the way up to jack, king, queen. 13 cards, and then they repeat. So on and so forth. They repeat 4 times. So there's 52 cards total. There's 13 cards in a pattern before they repeat. Now this pattern is called a suit. So there are 4 suits in total: hearts, clubs, diamonds, and spades. There's 4 suits in total. Each suit has 13 cards in it. Okay. And the last thing that you need to know is that these cards at the end, jack, king, and queen, are called face cards. So each suit has 3 face cards. Now there's 4 suits, which means altogether there's going to be 12 face cards. So those are some basic facts about the deck. There are 52 cards in total. There's 4 suits. Each suit has 13 cards in it, and then each suit also has 3 face cards. Okay, all the suits are identical as far as which cards they have, so they all have an ace, they all have a 2, they all have a 3. The only difference is the picture that goes with the card. So in this case, it's a heart. In this case, it's a club, et cetera, et cetera. Okay, so that's just a quick overview of a deck of cards. Knowing that is going to be helpful as you count out different probabilities, all right? Now, it is totally acceptable if you need to jot those facts about those cards down into your notes for you to do that. It's also totally acceptable for you to not write it down, but then reference this video if there's one of those facts that you need to know for your homework or for the quiz associated with this material. It is not a learning objective, going back to our learning objectives, it is not a learning objective that you know the way a deck of cards is put together. But you are going to see questions that use deck of cards. All right, so let me know if that becomes a problem for you. Shoot me an email. I'll do my best to try and help with that. But here's our third and final example. Okay, so what is the probability of drawing a card at random? So I'm just going to draw a random card from a standard deck of cards. What is the probability that I do that and I get a red 3? Let's do this. Let's say a red face card. A red face card. Okay, so the probability that I draw a card from the deck of cards and I get a red face card. So you may want to pause the video and give this a try on your own once you've tried it, or once you've gotten stuck, whichever comes first, and then go ahead and resume the video. All right, so I said on the last problem, I tend to figure out the thing in the bottom first. So if we think about this deck of cards, if I'm going to draw one card at random from the deck, whatever card it is that I choose to draw, if I draw one card at random from the deck, then there are a total of 52 cards in the deck. That means there's a total of 52 possible outcomes that I could have when I draw these cards. Okay, so the bottom of my fraction is a 52. Now, a red face card. So one thing I forgot to mention when I described the deck, in our 3 suits, or I'm sorry, our 4 suits, there were spades, there were diamonds, there were clubs, and there were hearts. Notice that 2 of the suits, spades and clubs, are black. 2 of the suits, diamonds and hearts, are red. So we're looking right now at this problem at just the red cards. Just the red cards. Okay, and we want to find a red face card. Well, we already said each suit has 3 face cards, the jack, the king, and the queen. So each suit has 3 face cards. So if there's 2 red suits and each suit has 3 face cards, then that means there's 6 in total as far as the number of face cards that are red. 6 red face cards. So I'm not going to list them all out here, but there's a king of hearts, a queen of hearts, a jack of hearts, and a queen of diamonds. Sorry, king of diamonds, queen of diamonds, jack of diamonds. Okay, so 6 red face cards all together. So there's my fraction. There's 6 desirable outcomes, red face card, and there's 52 possible outcomes, any card in the deck. So now this is one that I'm not going to be able to simplify in my head. Maybe if I spent a little time and thought about it, but I'm just going to divide it on my calculator. So 6 divided by 52 looks like it's going to be somewhere around 11.5%. But we're going to write that as a decimal. So we're going to say the probability is approximately 0.11, let's go 0.115. That rounds off in accordance with the SAT grid style round. Okay, so there is our 3 examples associated with how to calculate probability. In every single case, I calculated it by making a fraction, and the fraction that I made is based on this functional definition that probability will be equal to the number of desired outcomes divided by the number of total possible outcomes. All right, so that takes care of our introduction to probability. Thanks for watching this video. Have a good one.